All right, here we go. We're just going to start with a problem right off the bat. I want you to take a picture of that, and we're going to talk about this problem. In many ways, I tried to find the pizza one, but I couldn't find it the way I wanted it to be, where they asked how many different toppings, how many different kinds of pizza you can order based on so many toppings and pizza crust styles and that kind of thing. I couldn't find that one. So I'm using this one about paint. And this one's actually going to be somewhat useful to you, because how many of you have ever painted your room before? See, did you get to pick the paint out? Did you pick the color? Did you pick the sheen? Yeah. How shiny it is or not shiny? Did you get to do all that? Well, that's what this is all about. Okay. Now, this problem is just a counting problem. Yeah. All right. We have certain colors. We have a certain type. Surprised I didn't put water-based up there, but latex and oil, those are similar actually. Texture, you have flat, and so that's the sheen. Flat, semi-gloss, high gloss. High gloss means it's shiny. Flat means it's not shiny at all. Semi-gloss is in the middle. Used for indoor or outdoor. You know that there's certain paints you're supposed to use outside and certain paints you're supposed to use inside. Do you know that? Yeah. Okay. So how many different kinds of paint can you make, assuming you have to choose one of each of these? Okay. Now, here's how this works. Simple counting type problem. The way I like to think about these things is that each category is a slot. And each slot has so many possibilities. Right? So how many possibilities are there for color? 7. How many different types are there?
2.
How many different textures? And how many different uses?
2.
Okay, so in a counting problem like this, where you're given so many different types, all you got to do is plug those numbers into each slot, each category, each slot. Slot's the best way. And then what are we going to do with them? Multiply them. So when we talked about some of these problems the other day, when we made a tree diagram, when we drew, you could do that for this, okay? We weren't ready to talk about it yet. I wanted to get to this place. But the reality is, when you know how many, so for example, on your quiz about 3 questions that they were true, false, each slot had 2 possibilities, right? 3 questions, that means it's 2 times 2 times 2. You should have come up with a sample space that contained 8 different possibilities. Okay, and the same thing works there. We talked about it with the heads and tails and the boys and girls and the family and all that stuff. It's just there's 2 choices for each slot. Okay, and so we could create the sample space knowing what our number is that our target is. Okay, so these are the easier types of problems. Okay. Any questions? Okay, we need to shift gears a little bit. Talk about something called factorial. Is anybody familiar with factorial? A little bit? Okay. The notation is an exclamation point. That means factorial. And when you see that notation, I'm going to give you a couple examples and show you exactly what it means. Okay? So when we say, for example, here, this is 5 factorial. What this means, instead of writing the whole thing out, it just means 5 times 4 times 3 times 2 times 1 all the way down. 9 factorial, same thing. 9 times 8 times... So you just drop down to the next integer until you get to 1. That's what the factorial is. Okay? We're going to use that for the next couple things that we're going to look at, and it's a convenient way of writing basically a large multiplication problem out. Okay? The general form, the sort of rule for factorial is this. For any number, any integer n, factorial is just n, then the next number down is n minus 1, then the next number down is n minus 2, all the way down till you get to 1. Just like what it says up here. Start with the first number, work your way down by multiplying, and there is one exception, one special rule. Okay, and that is that 0 factorial equals 1. we have to make up 0 factorial in order to not be multiplying stuff by 0.
So the formula,
Yep.
the formula up there in the little box is literally just exactly what you wrote up.
Yep, just for any n. All this means is for any integer n, you just keep going down one, down another one from that, and you just kind of keep
So
working.
what if it's like super?
Right.
Do you want us to work all of them out?
We're gonna show you some examples about how that's gonna work here in a minute. So right, so one of the issues is this, if this was 70 factorial, you don't want to be writing out 70 numbers. Most of the time you're not going to have to. I will tell you that your calculators have a factorial button. On your graphing calculator, it should be in the math menu. Okay, and if you have trouble looking for it, finding it, let me know. I will help you find it. Most of the time, like I said, on your graphing calculators, it's in the math menu, and it's just an exclamation point, and you can find it. Sometimes there's a button, but I think you have to go into the actual math menu to find it, and it's in the probability menu. Okay. All right, that's factorial. And in order, we need to know about factorial in order to do the next 2 things that we're going to do that are in this section. And the first one is a permutation. Okay, a permutation is an arrangement of n objects in a specific order. The order matters. The bottom line is the order matters. And that's what I want you to take away from the idea of permutations. Now, so I said we're going to talk about the mega millions. Okay, does the order matter for the mega millions in which you get the numbers? No, you just got to get the numbers. Doesn't matter what order you have them in, you just got to get them. Right? When they draw the balls out, they don't necessarily come in a certain order. They just draw the balls out. Okay, so the order for mega millions doesn't matter. Okay, which is why it's not a permutation and it's a combination, which we're going to get to here in a minute. Okay, so here's an example again. Again, take a picture of that, and we'll talk about how this works. All right, so here's this situation. There's a news director who's got 3 stories that he wants to air. One's going to be the lead. Then there's going to be a second story. And there's going to be a closing story. He's got 8 stories to choose from. How many possible ways can the program be set up? There's a couple ways to look at this problem first, and then I'm going to show you one way using the counting principles that we did for the paint, and then I'm going to show you how it applies as a permutation. Okay. So I have 3 slots. Okay. Actually, I'm gonna get that out of there. Let's make this. The first slot is the lead. The second slot is the second, and the third slot is the closing. Okay. So when he's going through and choosing, how many possibilities are there for the lead story? 8. There are 8. Okay. So of those 8, he chooses one of them. How many stories are now left for the second slot?
7.
And how many for the closing slot? Okay. Right? Simple enough. The order matters because if you choose a different story for the lead slot, that changes the show. So in reality, what we're doing here is 8 times 7 times 6. There are 336 possible ways that this news director can choose the shows. Okay? Now, you can do it this way. I want to show you the permutation formula, and then we're going to work through the permutation formula for this problem just to show you that you get the same answer. Okay? So let's look at the permutation formula. And there it is. Go ahead and write that down, and I will talk very specifically about what all that notation means. So we're going to use the television show choices problem as an example to work through here. Okay? So n, permutation of n objects, and you're going to choose r of them. Okay? So in the television show problem, what is n? 8, because there's 8 shows to choose from. how many get chosen? So R equals 3. Okay? So for the TV show problem, N would be 8, R would be 3 because you're choosing 3 from 8. Sometimes this is read as a permutation of 3 choose 8. 8 choose 3. Okay? So all you have to do then is plug 8 in for N. We already know the answer, right? We know that the way we get it is 8 times 7 times 6. I'm just wanting to show to you how the permutation formula works to give us that answer. Okay? So on the bottom, so I have 8 factorial on top. What's the bottom going to be? 5 factorial. 8 minus 3. Okay? So a permutation, 8 choose 3, is going to look like this, which is 8 factorial over 5 factorial. Now, you could just punch that in your calculator once you find the factorial button, okay, and do that division in your calculator. That is certainly one way you can do it. Okay, but I want to show you something else as well. All right. Since I have this 5 factorial on the bottom, what I can strategically do, since 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I could write it out. Well, what is 5 times 4 times 3 times 2 times 1 in factorial? 5 factorial. So this is really 8 times 7 times 6 times 5 factorial. It's the same thing, right? It's still 8 on down to 1. And essentially, so this gets to your question about big numbers. Oftentimes they're going to cancel out. A big chunk of them are going to cancel out. Okay, and so I'm still left with the 8 times 7 times 6. Now, you could use the permutation formula. You can use the slot idea like we did. I'm just trying to show you that you end up getting the same answer. Okay, and so this is still 336 using the permutation formula. Okay. Now, since I've talked about your calculator and the factorial button, there is a permutation button. Okay. Be careful when you use it though. It's all under the math menu. And under the math menu there's a probability menu. Okay? And under that probability menu you're going to find those things. But you still need to know how to work it. You still need to know how to do it by hand. So be careful. I'm going to caution you on that. I'm not going to forbid you from using it, but I'm going to caution you on using it because you still need to do it this way. Okay? Any questions on permutations? Let's look at an example. Okay? Once you get this one situated in your notes, go ahead and work through it. See if you can get it. Again, the question you need to ask, does the order matter here? If the order matters, it's a permutation. If it doesn't matter, it's a combination. We're getting to that in a second. Well, we're doing a show in the fall and a show in the spring, right? Like if you switch them around, that makes a difference. Okay? So we're looking at a permutation. 9 things, we're choosing 2 of them. How many had that? Okay.
So it's just 9 times 8.
It is just 9 times 8. Because again, this is 9 times 8 times 7 factorial. So you don't need a calculator to do this, right? The 7 factorials just cancel out. And you get 72. So there's 72 possibilities that this musical director could use. Okay?
That's a lot.
How many had that? Alright, good.
I use the column thing.
Let's talk about combinations. We're getting closer to teaching you how to win the Mega Millions. Selection of objects where the order does not matter. Okay? So again, those balls come out of the pit thing, I don't even know what you call it, a little blower thing where the balls come out for the Mega Millions. The order that the balls come, okay. The order that those balls come out don't matter. You just have to have those balls. It doesn't have to be in that order. Okay? So you just need to get those, you just need to match them up. Alright. Another way to think about it is the difference between choosing a committee of 3 people that was like the president, vice president, and treasurer of a group. That order matters versus a committee of 3 people that make a decision where the order doesn't matter. Okay? We're going to talk about the Mega Millions. Yes?
You have a higher chance of winning Mega Millions by picking your own numbers.
We're going to get to that. Okay. So here's how the Mega Millions works. In case you were unaware, that's really small. So it's not you don't necessarily need to get that in your notes, okay? Because we're going to work through it. But here's what it is. You pick 6 numbers from 2 separate pools, okay? So you pick from one pool of 5. You pick 5 numbers from 1 through 70. That's sort of the normal balls. Okay, then there's a separate pool of 25 balls. That's I don't even know what they call it. It's like the Powerball for Mega Millions. I don't know what but it's a separate ball, probably a different color and everything, right? So we're going to talk through how to win the jackpot of getting first of the 5, what the possibility is of those 5 numbers, getting those right, and then you're going to have for each of those you have 25 ways for the last ball, right? Because you have this combination of all these 70 numbers that you choose 5 of them. But then you have to take that and you multiply it by 25 because you have this extra ball sort of over here, okay? Let's look at the combination formula first, okay? The combination formula is very similar to the permutation formula. The biggest difference, however, is we have this extra r squared down here. Let me highlight it instead. Okay, that's the difference between the combination formula and the permutation formula. When we divide by r factorial, what we are doing is eliminating all of the different permutations that contain the same values. All right? Because the order doesn't matter. So think about the true-false questions. When we said the order, a true, true, false, true, and false, true, true, were all considered different. Okay, I'll write those up there. So if I had this on a test, these are all considered different order because the order matters. But there's only one false in each one. In a combination where order doesn't matter, those would be like duplicates. There's only one way, when the order doesn't matter, to get a question with 3 questions to have 1 false. Okay? So what we would say in a combination, if order doesn't matter, is we'd throw 2 of those out. Because it still only has 1 false when the order doesn't matter. And that's what that r factorial does. It throws all those other ones out. Okay? That's what the combination formula does. Alright. So, for the 5 balls, we're just going to talk about the 5 balls right now. Okay? We're going to have 70 numbers to choose from, and we're going to choose 5 of them. So 70 is my n, 5 is my r. So go ahead and plug that into the formula. Don't use your calculator just to come up with the answer. Just plug it into the formula. Let's work through that a little bit. So again, the difference between permutation and combination is 2 things. 1, the order matters for permutation. The combinations, order doesn't matter. 2, the formulas are different, but not by much. The combination formula has that extra r factorial on the bottom. All right. So when I plug it in, it's going to look like this. 70 factorial over 65 factorial times 5 factorial again on the bottom. Okay. So the permutation piece would have just not had the 5 factorial on it. Okay. This number, when we do all the math, is 12,103,014. Okay? So, for the 5 numbers, just the 5 numbers that we choose first, there's 12 million possibilities. Okay? Now, we haven't even included that 25th sort of Powerball, Mega Million ball. I don't know what they call it. Okay? Because for each one of those 12 million choices, there is now 25 other choices for that last ball. So in order to find the total number of possibilities in the Mega Millions, I have to take that times 25. Yes. Okay.
Now, how did you just put in your calculator?
Yeah, I did for that one. Yep. And you could put 70 with the factorial button divided by, and put it in parentheses. Be careful. Make sure that you're dividing by that 5 factorial too. So when you enter it in your calculator, you probably want to enter the bottom all in factorial, or all in parentheses, so that it's dividing by all of that. Okay? Now, so I take that 12,103,014 times 25 because of each of those balls, and I get 302,575,350 possible combinations of numbers. Okay. This means, okay, if I wanted to guarantee that I win the Mega Millions, I have to buy 302,575,350 tickets. Now, so I say, okay, it was up to 1 billion. Why wouldn't someone just buy those tickets? First of all, you have to fill out, because you have to fill out 302 million cards, which I'm sure you couldn't do. I don't know if you could walk up to the person at Publix and say, I'd like 302,575,350 tickets, please, and I want them all to be different. I don't know that you can do that. I also don't know anyone that has that much money, okay? And each ticket is $2. So you need twice as much as that to cover it all. Okay? Now still, let's think about it. For tonight's drawing, it's $1.6 billion. Okay? It's going to cost you $604 million to guarantee a win. And if you lose 40%, let's say you lose half. Let's say you pay half in taxes. So that's $800 million. Okay? You're still going to win close to $200 million if you're the only winner. Okay? Most of the time, there's not just one winner, right? You're going to have to split it. And now for this one, like I said, I have 665 chances of winning today. But of those chances, I'm splitting one group with 56 other people, and I'm splitting another group with 9 other people, 18 other people, I can't remember. And then my 5 tickets that I bought myself. My wife's probably going to buy some too. Okay, so the odds are still very bad with one ticket out of 665 tickets out of that 302 million. They're still not very good, right? But the bottom line is, I told you I would tell you today that I would guarantee you a way of winning the Mega Millions. Well, I did. So the question is, well, why didn't you win it yet? Well, one, I don't have $600 million. 1. 2, I don't have the time to fill that out. Right? Like, it's that could be a full-time job right there, just filling out the Mega Millions tickets to get it filled. I don't know how long it would take you if you did one every 30 seconds. So you got 2 done per minute. And you'd have to fill out 300 million. Like, that would take a long time to do. Okay? So that's how you win the Mega Millions. You can do the same kind of thing for Powerball. I think Powerball, there's only 69 numbers, but I think there are 26 Powerballs. So the difference here would be, this would be 69 instead of 70, and instead of multiplying by 25, you'd multiply by 26. So if you want it, and they have all the odds and probabilities on their website. Not done yet. Here's the thing. I want you to write this down. We've talked about it, but I want you to write this down in your notes. The biggest difference between permutations and combinations is whether or not the specific order matters. Again, we talked about this, but I want you to get it down. If the specific order matters, then it's a permutation. If the specific order does not matter, then it's a combination. I want that explicitly in your notes so that when you go to do the problems tonight, you can remember which one to use. Okay? And now I'm done.